Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of object-oriented software engineering. We'll dive into key concepts like use case diagram, activity diagram analysis, class model. Let's get started. Slide 1. Use case diagram, introduction and components. Let's begin with use case diagrams, a fundamental part of UML used for representing the functional requirements of a system. A use case diagram gives a visual representation of how users, called actors, interact with the system to achieve specific goals. First, actors are entities that interact with the system. They can be human users like customer, or other systems interacting with ours. For example, in an ATM system, customer is an actor. Next, use cases describe actions or services the system provides to actors, for instance, withdraw cash, or check balance. System boundary is like a box that defines what is inside the system and what is outside its scope, helping us limit what functionalities we need to focus on. Relationships connect actors and use cases, showing how interactions flow. The association line connects an actor to a use case, indicating a direct interaction. We also use include when one use case always uses another, like verify user is always part of withdraw cash. Extend is used for optional behaviors that may or may not happen, like print receipt might extend withdraw cash. Finally, generalization helps in defining common behavior among actors or use cases. For example, admin and user, generalizing to person. So, use case diagrams help us capture what the system must do, and show how different users will interact with it. Slide 2. Advantages and disadvantages of use case diagram. Now let's look at some advantages and disadvantages of use case diagrams. Advantages. 1. First, they simplify complex system functionalities, breaking them into understandable parts. 2. By focusing on user interaction, they improve system usability. 3. They are very useful during requirement gathering, making sure stakeholders and developers are on the same page. 4. They help in the early detection of missing or incorrect functionalities. 5. By offering a visual tool, they improve communication between technical and non-technical team members. 6. They make system scope clear, outlining what is and isn't included. 7. They act as a foundation for system design and testing. 8. They help in tracking requirements throughout development. 9. Easy to explain to clients and non-technical stakeholders. However, there are limitations. 1. They don't show internal details or flow of events within use cases. 2. They can't depict sequences of activities inside a function. 3. Non-functional requirements, like performance, are hard to represent. 4. Sometimes oversimplifying can hide important system complexities. 5. They're not fit for detailed logical or technical design. 6. Actors and use cases need clear explanations to avoid misunderstanding. 7. If systems are too large, diagrams become crowded and unreadable. 8. They need constant updates as the system evolves. 9. And often, they need supporting diagrams to give a complete picture. Slide 3. Activity diagram, introduction and components. Moving on to activity diagrams, which are also part of UML but focus on showing the workflow or process flow within a system. Unlike use case diagrams that focus on what the system does, activity diagrams show how it is done. Key components include start node, shown as a filled circle, marks where the process begins. Activities are tasks or actions performed, like enter PIN, in an ATM process. Transitions or arrows show the flow from one activity to the next. Decision nodes represent points where a choice must be made. for instance, is pin correct. Merge nodes bring different flows back into a single path. Fork nodes split the flow into parallel activities, like verify balance and print receipt, happening simultaneously. Join nodes merge parallel activities back together. End node, shown as a circle with a border, marks the end of the activity flow. Finally, swimlets divide the diagram into sections based on who performs which activity, like separating customer activities from system activities. Activity diagrams are essential for understanding the process flow, identifying steps, and optimizing workflows. Slide 4. Advantages and disadvantages of activity diagram. Let's now discuss advantages and disadvantages of activity diagrams. Advantages. 1. They provide a clear picture of workflows, making complex processes easier to understand. 2. They are great for showing parallel processes, which are common in modern systems. 3. They help analyze control flow, showing where decisions are made. 4. They identify decision points and their outcomes, which helps prevent errors. 5. They are useful in business process modeling, beyond just software design. 6. Swimlets clarify roles, showing who does what in a process. 7. They highlight bottlenecks, making it easier to improve efficiency. 8. Non-technical stakeholders can easily understand them. 9. They help in designing and analyzing system operations before coding. However, disadvantages. 1. They can't show structural relations like class diagrams. 2. They focus only on behavior, not data structures. 3. Time constraints or delays are hard to depict. 4. Large workflows can make diagrams complicated and crowded. 5. They don't focus on object interaction or method logic. 6. Other diagrams are often required for complete system modeling. 7. Handling complex concurrency can confuse readers. 8. Need regular updates to stay accurate as systems change. 9. Requires careful planning to define activities and flows clearly. Slide 5. Analysis class model, introduction and elements. Now let's talk about analysis class model, which is a static structure diagram used to identify and organize classes during system analysis. It focuses on what classes are needed, their properties, and relationships, but without going into coding details. Main elements include 1. Classes, which are blueprints for objects, like customer. 2. Attributes, which are data properties of classes, like customer name, account number. 3. Operations or methods, which are functions classes can perform, like login, transfer funds. 4. Relationships connect classes to show how they interact. 5. Association means one class, uses, another, like customer, uses, account. 6. Generalization, inheritance, allows one class to inherit features of another, like savings account, inheriting from account. 7. Aggregation, composition show whole-part relationships, e.g., library, contains, books. 8. Multiplicity indicates how many instances are involved, like one customer can have multiple accounts. 9. Constraints define rules for attributes or relationships, for example, balance cannot be negative. Analysis class models are crucial because they give clear understanding of system structure, helping in moving to design and implementation phases. Slide 6. Differences, use case, activity diagram, and analysis class model. Finally, let's understand how use case diagrams, activity diagrams, and analysis class models differ because they serve different purposes. First, use case diagrams focus on what the system should do, that is, they define functionalities and interactions with users. In contrast, activity diagrams describe how those functions or processes are performed, including steps, decisions, and parallel flows. Then, analysis class models focus on the system's internal structure, identifying classes, their properties, methods, and how they relate. Talking about focus, use case is about interactions and system boundaries. Activity diagram is about process flows and control logic. Class model is about static data structure and relationships. Also, elements differ. Use case uses actors and use cases, activity diagram uses activities and flows, and class model uses classes, attributes, and methods. In terms of usage, use case diagrams help during requirements gathering. Activity diagrams are used in design and process analysis. Class models are critical during system analysis and design. Together, these diagrams provide a full picture, from what the system does, to how it works, to how it is structured internally.